look on the right-hand side. The minimum number of oxygens I could take is 2. So I decided, notice this star here, I decided I have to take a minimum of 2 oxygens. So 2 times 2 means a loss of 4 electrons. How can I gain 4 electrons? 1 times 4, 4 manganese. So I had a little finagling here. Now I could have started with a 1 for the oxygen and change it later, but I knew I was going to have to take a minimum of 2 oxygens on the right-hand side. Started with 2 right away. Okay. Now, this is an if statement. Can I really take 2 oxygens on both sides? Okay. And can I take 4 manganese on both sides? So here comes the next line. And so I did what the boxes say. I took 2 oxygens by taking 2 waters, and that gives me 2 oxygens on both sides. I took 4 manganeses by writing a 4 here and a 4 here. Okay. Now to do a little cleanup, I'm depending on the hydrogens to get the hydrogens to balance. And notice on the left-hand side, I have 2 times 2, 4. So this has to be a 4. Okay, now we're halfway done. This equation balances by mass. Check it out with me. 4 hydrogens, 4 hydrogens. 4 manganese, 4 manganese. Check the oxygens with me. We have 2 oxygens here, plus 4 times 4 is 16, that's 18. And we have 4 times 4, 16, and 2 more 18. So it balances by mass. But guess what, folks? In an ion equation, you got to make sure it balances by charge also. Let's check out the charge balance. So 4 times negative 1 gives a total negative 4 on the left. And 4 times negative 2 is a negative 8. But the hydrogens gives us a plus 4. So negative 4 balanced with negative 4. Now, in reality, if you've done the mass balance correctly, the charge balance should check out also. But I've seen cases where people make a mistake on the mass balance and they kind of catch it by looking at the charge balance. So you're really compulsive. You want to make sure both balances work, the charge and the mass balance. Okay, as far as the agents go, let's see. Water was oxidized because oxygen went from negative 2 to 0. So if water is oxidized, it must be the opposite kind of agent, reducing agent. And if manganese reduced, it must be the opposite agent. So Mn4 is the oxidizing agent. Okay, that was mini superkiller. Are you ready for superkiller? Okay, here we go. The supreme challenge is coming up. Okay, so at first glance, it doesn't really look too bad. There isn't really much to the equation itself. Okay, so let's use the rules of priority to figure out who's changing state. Now notice we've got a great thing going on here, and that is the iron is already given to you as a +2 and a +3. So oxidation is obvious. The iron's really done. Now on the left-hand side, we had to figure out the manganese. Okay, how do we do it? Okay, well the worksheet would look like this. Okay, there are 4 oxygens times -2 is a -8. You're given the total charges have to be -1. It's an ion. Conclusion, manganese is a +7. And so there's only 1 manganese to carry, +7. So manganese goes from +7 to +2. So far the equation looks really, really simple. Okay, here's the next line. Okay, so summarizing, manganese goes from 7 to 2. That's a change of 5 electrons per manganese. Iron goes from +2 to +3. That's a change of 1 electron per iron. What's the numbers 1 and 5 suggested to you? Switch the numbers. So how about if we take 5 irons, 1 manganese, 1 times 5 gives us 5 electrons that are gained, and 5 times 1, 5 electrons that are lost. Okay, so I'm now going to take those numbers that are in the box, the red boxes. So 5 irons, 1 manganese, 1 manganese. We're done. Except for, why did Berg put this double question mark on the oxygen? Where in the hell did the oxygens go? We don't call this super killer for nothing. Yeah, where did the oxygens go? Everyone understand what the problem is? The oxygens don't balance. Where did the oxygens go? The answer goes like this. You are looking at what's called an incomplete reaction. Now, if you need extra oxygens, Da-da-da-da. You're allowed to throw in water. Doesn't sound right, doesn't it? Okay, you got to remember that 95% of the time in chemistry, water is a solvent. We usually do chemistry in water as a solvent. Now, sometimes just being a solvent, water can be involved in the reaction itself. So in this case, we needed to have 4 oxygens in the equation to balance it, so you put 4 waters on the right-hand side. So the rule is if you need extra oxygens at the end, you're allowed to throw in water. In other words, I actually gave you what's called an incomplete reaction, which I like better because they're kind of smaller, they're kind of shorter, and then later if you need oxygens, you're allowed to throw in water. Slight problem. By throwing in water, it still doesn't balance. Why not? What's missing, fans? That was not a hard question. What's missing?
Hydrogen.
That's right. So here's rule number 2. If you need extra hydrogen, you're allowed to throw in hydrogen ions, otherwise known as acid. So maybe this is going to be an acid reaction. We just didn't tell you this to begin with. So notice what I did. From the 4 waters on the right, we picked up 8 hydrogens, so I throw in 8 hydrogen ions. Okay. Now notice, this is now a balanced equation. Double check it with me. 8 hydrogens on the left, 4 times 2, 8 hydrogens on the right, 1 manganese, 4 oxygens on the left, 4 oxygens from water on the right, 5 irons, 5 irons. Okay. Now, sometimes, oh, how about the charge balance, by the way? The charge is balanced? Let's see. The 5 irons give us 5 times 2, 10, plus 8, 18, minus 1, 17 on the left, and 5 times 3 is 15, plus 2, 17, so it's balanced. Now, sometimes we ask someone to balance the equation not in an acid solution, but in a basic solution. All right, I didn't spell this correctly. That should be a C, not basis, but basic solution. So please, in your notes, change that S to a C, basic solution. Now, I have to confess something to you. I was absent the day they taught us how to write a basic solution. By the way, to balance a basic solution, what do you think you use? You don't use hydrogen ions. What do you think you use? Hydroxide, right, okay. Now, what I want to show you is this. I'm going to show you how to convert an acid solution to a basic solution. It's really simple. You can do it in 3 simple steps. Step number 1 goes like this, okay? If it's supposed to be a basic solution, you can't have acid. So how can you neutralize the 5 hydrogens? Add 5 hydroxides. That'll get rid of the acid. But to be fair, if you're going to add 5 hydroxide to the left, you have to add 5 hydroxides to the right. By doing that, you still balance the equation. Now, the next step goes like this. What happens between hydrogen and hydroxide? Yes, they will react to give you water. So 8 hydrogens, 8 hydroxides will give us 8 water. So you want to do that chemistry. Now, there's usually going to be a cleanup step that goes like this. You don't want to have water on both sides. So notice we got 4 waters on the right and 8 waters on the left. Subtract 4 from both sides, you'll have a net of 4 waters. So the final answer would look like this. So let me take you through those 3 steps again. Step number 1, if you want a basic solution, neutralize the hydrogen with hydroxide. So 8 hydrogen, neutralize 8 hydroxides. That's step number 1. But you got to add hydroxide to both sides or you'll have an unbalanced equation. Next step, do the chemistry. Hydrogen plus hydroxide gives you water. And generally you'll end up at this point with water on both sides. Subtract the smaller number from both sides and you'll end up with the final answer. Okay? And if you're compulsive, you can double check this at this point, element by element, but I think you'll see it as correct. Okay, so if someone asks you to balance in an acid solution, you're going to use oxygen for extra. If you need oxygen, you can use water. If you need extra hydrogen, you can use hydrogen ions. And if they ask you to make it a basic solution, you can do these steps to do that. Okay, now you've just seen the half reaction method. The problem with the half reaction method is sometimes it won't work because you'll run across a compound in which you can't use the rules of priority. For example, if you came across silver sulfide, silver's not on the list, either is sulfur. What are you going to do? You can't use the method. Now, you might be lucky and be able to guess these from your knowledge of the periodic table, but If you can't do it, let me show you what we're going to do. I'm going to teach you a second method. The second method is called the half reaction method. Here's the overview. Let's say here's the overall reaction. A plus B gives you, I'll call it A minus and B minus. This method says you're going to break it up into two halves. So A goes to A minus, and then B goes to B minus. With this method, you break it up into two halves, you balance the two halves separately, and then you stick them together at the end. Now, unfortunately, this method doesn't work all the time, always. Also, okay, let me give you an example. Let's say the reaction is A plus B gives you AB. So you decide to break them into halves by having A go to AB. But where's the B going to come from? You got to write B here, okay? And second half reaction is B goes to AB, but at balance you have A here. Notice what happens. You're writing the overall reaction twice. The point I'm trying to make is neither method works 100% of the time. So that's why I'm teaching you two methods. If one method fails, you use the other one. Now, from my experience, I actually like the half reaction method better. The longer I teach, I think this is actually the better method. So my suggestion is on exam, try the half reaction method first. If it fails, then use the oxidation number method. Okay, so I'm now going to take you through the steps of how the half reaction method works. So here's the overall reaction. MnO4 minus plus iron plus 2 gives you iron plus 3 plus Mn. Step number 1 is to break it up into two halves. By the way, that's the hardest part of this step. If you can do that, you got it made. So I'm going to break this into iron 2 going to iron 3. That's one half. The other is MnO4 goes to Mn plus 2. So if you have two reactants, put them in diff half reactions and line them up with the products that resemble the most. Okay, that's step number 1, break it up two halves. Step number 2 is to balance them by mass. Notice the iron is already balanced. Don't care about the charges, but one iron on both sides. So it is balanced by mass. Now the second one is not quite so easy. Okay, MnO4 goes to Mn plus 2. Okay, so the manganeses are balanced. The oxygens are not. So what did we learn before? If you need extra oxygen, you're allowed to throw in water. So I'm going to take 4 waters to get the oxygens to balance. Now the hydrogens don't balance, so we have 8 hydrogen on the right, so we'll throw 8 hydrogen ions on the left. So do you concur? They are both balanced by mass? So yes, that's step number 1 of this method. Step number 2 is something you've never done before. We're now going to balance them by charge using electrons. So look at the iron half reaction, okay? So it has a total charge of plus 2 on the right, plus 3 on the left. So we're going to cut the right-hand side down to size by adding 1 electron. So you always add the electron to the more positive side. So now they both total positive 2. Now how about the second half reaction? Well, let's see. It has a plus 7 on the left-hand side because the 8 hydrogens and the MnO4 give us total plus 7 versus a positive 2. It's out of balance by 5, so we're going to add the 5 electrons to the right-hand side. So both of these are now balanced by mass and by charge. Now here's a great double check. Okay, in the half reaction method, one half reaction should be giving off electrons, the other should be taking off electrons. So electrons should be on opposite side if you've done it correctly. Now, they're both balanced half reactions, but the electrons have to cancel out. Why is that? We must have conservation of electrons. It's not going to work for one to give off 1 electron, the other is going to need 5. So how do we get the electron exchange equal? Well, how about if we multiply the top one, everything by 5? Then we'll have 5 electrons on both sides, so we'll quintuple the top half reaction. Now, if we do that, what is this going to give us the final answer? Well, we're going to have 5 iron plus 2s and 5 iron plus 3s, okay? And on the bottom one, the electrons cancel out. We're going to have 8 hydrogens, 1 manganese, 1 MnO4 on the right-hand side, 1 Mn plus 2, and 4 waters.